Assalamualaikum. We are from Department of Chassis. For today's presentation, I, myself, Irfan Zikri bin Muhammad Fairahal, will be presenting about us and project management. Shahiran will be presenting introduction and product requirement study. Amza will be presenting product feasibility study and final design. And lastly, Hazim will be presenting engineering analysis and project costing. This is our team organization chart. Ayuni is our CEO. Hazim is our head of department. Amza as our design engineer, myself as secretary, and Shahiran as our research and development engineer. The Gantt chart that shows the flow of our project for the whole semester. For phase 1 conceptual design, we managed to follow our target from week 2 until week 5. For phase 2 embodiment design from week 6 until week 10. For product architecture, we managed to follow our target week. And for design configuration, conceptual design, and parametric design, we target for it to be 4 weeks each, but we managed to finish it early for 2 weeks, 3 weeks, and 2 weeks for each activity. Lastly, for phase 3 details design from week 11 until week 14, there are 3 activities that we overextended for a week, that is assembly of the drawing, bill of material, and detailed cost estimation. That's all from me.
Assalamualaikum. I am Ahmad Sharon Aizat bin Tajudin Arifin, and I'm gonna present about the introduction. First, what is chassis? Chassis is referred to a framework of a vehicle. It contains all structure and mechanical components that sustain the body. The chassis offer a robust and solid platform for the body, engine, transmission, and suspension components, which also aids in the equal distribution of weight and stress, enhance overall handling and stability. For the product requirement, general technical specification for this vehicle is for the dimension. The wheelbase range is 1000 mm to 2000 mm. The track width need to be 75% of the wheelbase. For the length, the maximum is 2500 mm. For the maximum width is 1500 mm. And for the height, the maximum is 1500 millimeters from the ground. For the vehicle weight without the driver, the maximum is 50 kg. The capacity for this vehicle is, for the seating, is only for one person. For the payload, the minimum is 30 kg. And for the storage, the minimum is 100 liter. For the chassis requirement, the type is only space frame, and for the material and shape, the material of the chassis is steel, and the shape is tubing or the square section. The roll bar, the roll bar need to extend 5 cm around driver's helmet and must be also able to withstand a static load of 700 Newton to make sure the driver is safe. For the driver visibility, the minimum field vision is 200 degrees.
Assalamualaikum warahmatullahi wabarakatuh. I am Amza bin Amran. So I will present the product feasibility study. For product feasibility study, we use the morphological chart method to determine which is the best option. So for the first component is the shape of tube. We have two options here, which is the square section and the circular section. We choose the circular section because it has better stress distribution compared to the square section, which means it's more stiffer compared to the square. So next, the component is the position of wheel. For this component, we discuss with the steering department whether they want to have 3 wheels or 4 wheels. So we choose a 4 wheel, so 2 wheels at front and 2 wheels at back. And next is the shape of chassis. At first, we want to choose the aerodynamic chassis, but we have some problem, which is that the driver will not have enough space to pedal the car. So we decide to go to the box option so that the driver have more space to pedal. And next is the design of cockpit. We have a roof cockpit and open cockpit, and we decide on roof cockpit because of a safety reason, and also it is more aesthetically pleasing because we want to make a buggy. And from this is our final design. This is our design. As you can see, we have all the component. We apply all the component from the morphological chart into our design. At first, you can see the shape of tube. We use circular section. And the position of wheels, we have 4 wheels, two at front, 2 at back. And it is a box shape to have more space for the driver. And we have the design of the cockpit. We have a roof on top so that it is more buggy-like, and also for safety reason in case of a crash impact. I think that's all from me. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Ifan Hazim, and I will explain about the engineering analysis or FAE of the chassis department. So for the analysis, there are 2 types of analysis that we have done, which is crash impact and frontal impact. And firstly, I'm going to explain about the frontal impact analysis. So, for the frontal impact analysis, first we have to find the force acted on the body, which is the force equal to mass of the final product and the acceleration assumed for the final product, which is mass include the driver equal to 250 kg, and the acceleration assumed is 1.3 meter per second square. And then we get the value of force, which is 325 Newton. And then the next step is we apply the force in front, on the front of the chassis. And then we get the von Mises stress maximum is 4.48 meganewton meter square. And then from that, we find the safety factor of the chassis, and the value that we get is 44,642.9 only. Next analysis that we have made is the roll bar crash impact. First of all, we have to find the value of force acted on the roll bar, which is 700 Newton. And then from the force, we get the von Mises stress maximum is 68.3 meganewton meter square. And from that, we substitute the value to the factor safety formula to find the safety factor, and we get about 2,928.3. Next, I will explain how we find the estimation cost. Firstly, we list all the materials that we are going to use, include the raw material and the tools material, and also the electricity that we use. So total is 4, which is the material we use, mild steel, and the tool material, which is MIG wire welding, and also the MIG gas welding, which is CO2, and of course electricity that we use. The price of those materials is RM4 per kg for mild steel, and RM6 per kg for the MIG wire welding, and 27 ringgit per liter of CO2 gas. And then the quantity of materials that we are going to use is 40 kilogram of mild steel, 15 kilogram of MIG wire welding, and 10 liter of CO2 gas. 10 liter of CO2 gas. And then the total that we calculate is the mild steel. We are going to use about 160 ringgit. For the MIG wire welding, we are going to use about 92 ringgit. And then for the gas, we assume that we are going to use about 270 ringgit. And for the electricity, it's about 150 ringgit. So by adding all of that cost together, we get the estimation cost, which is 672 ringgit total. That's all from me. Thank you very much.